Hi everyone, in this video we'll be deciding if the given vector over here lies in the span of the set inside the space. So this will be the span of vectors, and same as this, we are given this vector, we will see whether it lies inside the span of these vectors. Hence, in our previous video we have already learned how to express a vector in terms of its linear combinations in terms of parametrization. So let's do it again. So now we are given this vector and this span of vectors. We want to see whether this can be written in a linear combination of these two vectors. So hence, let's write it this way. We're doing parametrization. So 2, 0, 1 equals to A 1, 0, 0 plus B 0, 0, 1. And now let's expand again to a singular matrix, to a matrix form, a simplified one. So 2, 0, 1 equals to, so A times 1 equals to 1, B times 0 equals to 0, so equals to A. Let's take a look at the second row. A times 0 equals to 0, plus B times 0 equals to 0, so 0 plus 0 will give me 0. And the third row is A times 0 equals to 0, plus B times 1 equals to 1, so 0 plus B equals to B. So let's, from here, by comparing coefficients, we can see, by comparing the coefficients, we can see that therefore A equals to 2, B equals to 1. Therefore, since there's a consistent value of A and B, we can say that this vector can be written as a linear combination of these two span vectors. We can do a check by substituting this in the second row. So A times 2 times 0 equals to 0, 1 times 0 equals to 0 will give me 0. So hence, for the first one, it is proven that it lies inside the span of the set. Now let's take a look at the second example. The second example is familiar with what we did in our previous video, where we did a 2 by 2 matrix. So again, we write it in its linear combination in terms of parametrization, just like in here, A and B. So let's start off 0, 4, 1, 2, equals to A 1, 1, 0, 1 plus B 2, 2, 0, 3. Now let's see if we can express it in this way. Same again, we expand the vectors again, write it in the simplified form. 0, 4, 1, 2 equals to. Now from here, let's do the first row, first column. So A times 1 equals to 1. A times 1 equals to A plus b times 2 equals to 2b. So a plus 2b. Let's take a look at the vector in the first row and second column. So a times 0 equals to 0, and b, so plus b times 0 equals to 0. So 0 plus 0 will give me 0. And for this also, in the second row, first column, a times 1 equals to 1, and b times 2 equals to 2. So equal to a plus 2b. And for the second row, second column, a times 1 equals to 1, and b times 3 equals to 3b. So a plus 3b. Well, let's compare coefficients. For the first one, you notice that. So now let's start off for the first row, first column. We get a plus 2b equals to 0. And from the first row, second column, you get 0 here and here. So 1, 0 equals to 1. And from the second row, first column, you get a plus 2b equals to 4. And from the second row, second column, you get a plus 3b equals to 2. So you notice that from here, you can see that the solution is not consistent. Why? From here, a plus 2b equals to 0, 0 equals to 1, and this also. So hence from here, because of this inconsistent equation, inconsistency, hence you get inconsistent values of a and b. Therefore, the vector cannot be expressed in a linear combination of these two vectors here, and hence we can conclude that the vector does not lie in the span of this set inside the space. So now we have come to the end of this lesson. If you have any questions, please feel free to drop me a comment and I'll reply to your comment. That's all. Thank you.